Hey students, today we're going to talk about solving exponential equations, but before we begin that, I feel like we should review some rules about exponents. For example, when we're multiplying, what do we do with our exponents? Well, as long as the bases are the same, a is the base, we have a to the x times a to the y. When our bases are the same, we keep the base and we add the exponents together. All right, when we have division, when we're dividing, opposite of multiplying, when we're dividing, we subtract our two exponents. But again, the base has to be the same base, and we take the top power minus the bottom power. When we have a power to a power, as we do a to the x to the y, a power to a power, that sounds pretty powerful. We multiply the powers. So we keep the base, but we multiply the powers. When we are, when we have a problem like this, and we've got parentheses and everything is to the x power, we take everything to the x power. So that would be a to the x, b to the x. All right, over here, back over here, let's talk about negative powers. Anytime you have a negative power, it is the reciprocal of your base. So a over 1 is the base. The reciprocal of a over 1 is 1 over a. And now it would be to the positive x power. And vice versa. If your negative power is in the bottom, you still do the reciprocal of your base. So 1 over a becomes a over 1, and it would change to the positive x power. So, all right. Next, we have the 0 power. Any base to the 0 power is 1. Anything to the 0 power is 1. When we have a fraction and our fraction is to a power, we take the numerator and the denominator to that power. So that would be a to the x over b to the x. And this is an interesting problem. I always think of my top number as my exponent and my bottom number as my root. So if I were taking this and putting it in radical form, my exponent is the x, and my root is the y, and my a goes inside. So I always think words end in er. So my exponent over my root, exponent over root. So the x is the exponent and the y is the root. Exponent, root, like words end in er. Okay, let's see if we can't simplify a couple. Everything in here is going to be raised to the fourth power. So we're going to have 2 to the fourth power, x to the fourth power, and y to a power. We multiply them, so that would be y to the negative 8 power. 2 to the fourth means 2 times 2 times 2 times 2, which is 16. So that would give us 16 x to the fourth power. We don't like to leave negative exponents, so that would become over, this is doing the reciprocal, over y to the positive 8 power. All right, here's another one. In this problem, we're going to basically reduce the 8 and the 4. So 4 goes into both. 4 goes into 8 twice. 4 goes into 4 once. We're going to subtract. That would be x to the 3 minus negative 1 and y to the negative 5 minus 2 power. So that would give us 2 to the 2x to the fourth power, y to the negative 7 power. We never like to leave negative powers, so this one's going to drop down. Our final answer is going to be 2x to the positive 4 over y to the positive 7. Remember, negative powers mean to do the reciprocal. So we did. This one's super easy because the whole thing is to the 0 power. Anything to the 0 power is 1. Okay, here are a couple examples. We want to rewrite this, and this time I'm going to let you leave a negative exponent. A lot of times we don't like to, but this time we're going to. This would be 1 over, we're going to rename it 5 squared, and using a negative exponent, that would be 5 to the negative 2 power. And 1/8 would be 1 over 2 to the third. 2 to the third is 8. And we could rewrite it with our negative exponent. That would be 2 to the negative 3 power. If the power is positive in the bottom, it will be negative in the numerator. Now let's see how we can solve. Let's see how we can do these and solve. So this problem, we have 1 over, oh, it's being cranky. Okay, we have 1 over 125. I'm going to rewrite 125. That's the same as 5 cubed equals 5 to the x power. You know that 1 over 5 cubed, because we talked about our negative powers, that would be the same as 5 to the negative 3 power if I were to bring that up, or in other words, do the reciprocal. And 5 to the negative 3 equals 5 to the x. When your bases are equal, your powers are equal. So x is equal to negative 3. So our goal is to get our bases to be equal so that our powers will be equal. Because if I had, for instance, if I had 5 squared equals 5 to the x, then in order for these two to be equal, x would have to equal 2. Because 5 squared equals 5 squared. So when the bases are equal, the exponents are equal. So our goal is to get the bases to be equal. 32. 32 is actually 2 to the 5th power. Not 2 times 5. 2 times 2 times 2 times 2 times 2. 2 to the 5th. And then to the 3x. So all I did was rewrite 32. And on the right side, I have 2 to the x plus 5. Now we have a power to a power, power to a power. We multiply the powers. So that's 2 to the 15x equals 2 to the x plus 5. And when our bases are equal, our powers are equal. And I forgot to mention, this is called the one-to-one property. The one-to-one property, because they're in the same spot, they are equal to each other. So 15x would have to equal x plus 5. Now I do a solve for x. So minus x, 14x is equal to 5. Divide by 14, and I get x is equal to 5/14. And we'll just leave it as a fraction. That is more precise than some decimal. Here's one more. And I'll just tell you, I looked this up a minute ago. 6 to the third is 216. You're going to need a calculator. And 6 to the fourth power is 1,296. So I looked that up a second ago. So I'm going to rewrite 216. I'm going to rewrite it 6 to the third. And then it's still to the 3x plus 1 power. And I'm going to rewrite 1296, that's 6 to the fourth. But it's still to the 5x minus 2 power. All right, from above, we talked about when we have a power to a power, we multiply the powers. A power to a power, that sounds pretty powerful. Multiplying is powerful. So we'd have 6 to the 9x plus 3 equals 6 to the 20x minus 2. Minus 8. So in order for these two to be equal to each other, if we use the one-to-one property, I would know that 9x plus 3 would have to equal 20x minus 8. And now we simply solve, subtract 9x from both sides, so we have 3 equals 11x minus 8, add 8, and we get 11 equals 11x. Whoa, I just made this problem up, and look at that, x equals 1. I totally made this problem up. Anyway, you can always check your answers by plugging them into the original problem, and the left side will always equal the right side if you've got the correct answer. Okay, we're going to do some delta math tonight, so good luck with that.